Run! Hide! Wait, why am I hiding?
The physics police are coming.
Oh god! Yeah. Okay, hey, why are they coming?
I broke Coulombs' law.
You what?
Everyone thinks I'm sorry, yeah, I know.
Oh, what are they going to do to us?
It's quite a serious penalty, actually.
Is it?
We can either spend a year in physics prison.
Oh no, I don't want to do that.
No one wants to do that. Or, but the other thing they could do is give me a serious charge.
You can use that.
Take that.
Yeah, that's there forever now.
Clever cracker comedy.
Yeah, it's good. So Coulomb had a law.
And it was good.
Yeah, except it was a bit of a rip-off of Newton's law.
And I don't like that because I like Newton, so I hate Coulomb. That's how that works.
Yeah.
Coulombs, stupid name.
Yeah. So we have a particle, a charged one.
It has a charge, doesn't matter what it is, there's another particle with a different charge. It could be a proton and an electron, it could be slightly different negatively charged things, but there's two different charged things.
Yeah, and they're a distance of r away from each other.
They are indeed.
And they'll have some sort of effect on each other, attracting, repelling, a force will be there.
And so we can deduce, well I say we, Coulomb deduced from what Newton deduced, I think, that's my opinion, some nice little equations for the force between these two particles.
So you've got a couple of relationships.
We do indeed, so we can I say we again, Coulomb deduced.
I mean, we're doing it now, so it's okay.
It's fine. We rip off Coulomb, he ripped off Newton, it's fine.
Yeah, it's just lots of
Ripping off.
Yeah. So we have...
The force is proportional to the product of the two charges.
Yep, and I'm going to do it from colour.
Nice.
Force is inversely proportional
to the radius squared, which is the same as proportional to 1 over r squared.
It is. When we put these two things together, it looks very familiar. In fact, it looks very much like Newton's law of gravitation, except instead of two m's, we have two q's.
We do indeed. So we get that.
Yeah.
But here at the Clever Cracker Squared studio, we hate fish.
We hate fish, but luckily...
I mean, not living fish, we don't like,
yeah,
we're not fishermen.
Yeah, just proportional size.
Yeah, we hate those fish. How do we get rid of them?
Well, they hate Special K. They hate Kellogg's.
They hate Kellogg's.
We've got loads of Special K, so you throw some of that in there.
Yeah, so we get K, lots of.
Yeah.
Q over r squared. And you might be looking at your formula booklet going, well, bugger it, it's not there, I'm over.
Yeah.
Don't worry.
Don't worry, because this isn't there, and neither is that K.
No, and this K isn't actually the Boltzmann constant either, just to throw you off even more, because that is in there.
That is in there, so it has a different value. This K has a value of 8.99 times 10 to the...
10 to the 9.
10 to the 9, right.
So that's a value of this particular K. It's a particular constant for this particular thing. And again, this K isn't in your formula booklet, so this entire thing isn't in your formula booklet like this.
No, but what is in your formula booklet is another way of finding K.
Yeah, so what you could do is you could remember this, and if you can do that, this is actually going to be easier for you. But K also happens to equal 1 over 4 pi epsilon 0.
Yeah, and epsilon 0 is in your formula booklet.
Yep. So altogether we can replace K with this 1 over 4 pi epsilon 0 in this equation, and we get Q lots of Q over 4 pi epsilon 0 r squared.
We do indeed. Epsilon 0 has a value of 8.85. So
and that is your formula.
And yeah,
lovely.
That's there. So that's nice. So let's use it.
Let's use it. Now, you could use this as we've said, and if you want to remember what K is and then remember this equation, good for you.
Yeah, it's less number tapping, might be a bit quicker in the exam, but you might
less likely to make a mistake as well.
Yeah,
in terms of typing it in.
Mm-hmm.
But the majority of people will go for this one because it's in your formula booklet.
So we'll teach that.
Yeah, we're going to do a worked example and we're going to use that one.
Okay.
So as we said, those two charged particles could be anything. They could be ions or whatever they really want to be.
Okay, but let's say we're talking about hydrogen and there's a proton and an electron.
Yeah, so the neutron is neutral, so it doesn't come into this.
Yeah.
There's a proton in the nucleus and there's an electron whizzing around it. It's quite simple.
There's a proton, positive charge, electron, negative charge.
And it's whizzing around it, and it's whizzing around it at a radius of...
I'm going to call it R, but R has a value and that is?
5.3 times 10 to the minus 11 metres. Tiny, could run it really quickly, I reckon.
I reckon you do it so fast. Ow.
So that's the radius between them. And if we get up our equation, let's see what we know. That's always a good start.
Yeah. So our equation, as you just saw, was F equals QQ over 4 pi epsilon 0 r squared. Now we have RR.
Yep, we have this. 4 pi epsilon 0 is constant and epsilon is in your formula booklet.
Yeah, so we have all of the bottom row. We don't have the QQ, or do we?
It doesn't say explicitly what they are, but you do actually have Q and Q.
You do. So the Q, the charge of the electron, I'm stop saying Q now, it's a bit silly. The charge of the electron is minus 1.6 times 10 to the 19.
And that is in your formula booklet.
Minus
you can't
19.
remember it, minus 19.
Yeah, and the thing about electrons and protons is they've got the same charge but opposite.
Absolutely. So the proton is just 1.6 times 10 to the minus 19.
It is.
It's not negative.
It's not negative, and then normal things at the bottom, so I'm going to put that in the calculation now.
So it's 4 times pi times epsilon 0, 85 times 10 to the minus 12. Times the radius, 5.3 times 10 to the minus 11 squared. And it's just plotting numbers into the formula. The difficult part would be to find out what these two charges are, which just requires you to know that the proton is opposite to the electron. And that's that really.
It does, but it does involve a lot of number tappings. You may gain sometime by remembering the thing, and that gives us 8.89 minus 8.89 times 10 to the minus 8. I mean, I may have not typed that in correctly, but yeah, something like that.
It gives you a number. You can type this into your calculator and get an answer.
The process is the important thing there. So we've used this equation, so that's pretty good.
It's come up with a minus. You probably would get the mark if you didn't put the minus.
Yeah.
But I would keep the minus just to be strictly true.
Because forces are vectors are in direction.
And the electron is being pulled towards the proton.
Yeah, normally positive things move away from positive things.
So that's that new equation, Coulombs law in a nutshell. So that's great. I think we can go get a cup of tea. The physics lays down.